All right, today we're going to be looking at solving one-step equations, and we will be doing an introduction and solving some example problems as well. The first thing I want to talk about, though, is some of the rules or tips to follow when you're solving these equations. And these rules don't just apply to the simpler one-step equations that we're doing today, but they apply to solving most equations that you'll encounter in math. So the most fundamental rule that you want to follow is that you want to do the same thing to both sides. If you do something to one side, you have to do it to the other, and that keeps our equation balanced. It keeps our equation as a valid, true equality. And the way we'll be doing that is we'll be doing some inverse operations of what's being done to x. And I'll show some examples, and we'll look at what inverse operations are. And of course, we always want to show our work in math. That's super important. And our ultimate goal is to work towards isolating x. Let's get x by itself, and that'll tell us what x is equal to. And then, of course, at the end, we want to check our solution. And I'll show you a couple ways of doing that. All right, so let's get started with what some inverse operations are. And I've listed the 6 or so most common operations that we see in Algebra 1. And let's talk about what those inverse operations are. So for example, if you see something being added to x, you undo that by doing its inverse, which is subtraction. And similarly, if you see something being subtracted, we can undo that subtraction by adding it. It'll cancel it out. That's what inverse operations do. They cancel out the operation that's being done. The inverse of multiplication is division. And similarly, the inverse of division is multiplication. And we will also be seeing some squared and square root functions, maybe not in this first unit in Algebra 1, but certainly down the road we will be. And the way of undoing a square is to square root it, and the way of undoing a square root is to square it. Okay, so let's do some examples applying those inverse operations. So my first example, we have on the left side here, we have x plus 8 equals -3. So some mystery number x plus 8 added onto it gives us a -3. And we're curious, what is x equal to? So we see an x added on, and let's undo that. Or excuse me, we see an 8 added on. Let's undo that 8 by subtracting 8. And one of our most fundamental rules is if we do something to one side, we have to do it to the other side as well. So we'll subtract it from the other side as well. The whole point of subtracting 8 was to have those 8's cancel. We have an x remaining on the left side, and -3 minus 8 is -11. So that's going to be my solution. A formal way of checking that work is to plug that -11 back into x in my original equation, and let's see if it works out. Is -11 plus 8, is that equal to -3? -3, yes, is equal to -3, so it checks out. So my solution is a -11. It looks like we did it correctly. Over on this problem on the right here, we can see that we're subtracting a 4.6 from y. So let's undo that subtraction. Let's add that 4.6 back on. We will do it to both sides so we can keep our equation balanced. And these 4.6's cancel. We have a y remaining on the left, and let's do 5.3 plus 4.6. It looks like we get a 9.9 on the right. That's what y is equal to. A slightly less formal way of doing a check is to just do a mental check, plug it back in your mind. Is 9.9 minus the 4.6 equal to 5.3? And it is, it checks out. All right, let's do a couple more involving multiplication and division. As we said earlier, the inverse of multiplication is division. Here we have a 2.3x. That really means 2.3 times x. There's an implied multiplication symbol right in there. So let's undo that multiplication, and let's divide by 2.3. Of course, we'll do it to both sides. And we have some things cancel. My 2.3's cancel. We have an x remaining on the left side, and let's divide on the right. Let's see what we get on my calculator. I'm going to round to 2 decimal places. I think in general that's a reasonable way to round unless your teacher specifically asks you to do something different. But when in doubt, round to 2 decimal places. x is 6.09. I'm going to multiply that through by 2.3. I'm going to do a quick calculator check, and I do get a 14, so it does check out. Over on the right side here, we have y divided by 6 is -8, and we can multiply both sides by 6 to undo that division by 6. So these 6's cancel. That was the whole point of doing that multiplication by 6, and we get y is -48. A quick mental check is -48 divided by 6. Is that -8? It is. It checks out. Okay, so we did that one correctly as well. Moving on, we'll do a little work with reciprocals here. And let me actually remind you what a reciprocal is. A reciprocal is, in simple terms, it's just the fraction flipped upside down. Okay, so the reciprocal of 2/5 is 5/2. The reciprocal of 1/3 is 3/1, which is also equal to just 3. And the reciprocal of, say, a whole number like 5 is 1/5. Okay, so we're basically flipping the fraction, we're inverting the fraction. So we can solve these multiplication problems by multiplying by the reciprocal as well. So we don't need to do a division by 5, we could do a multiplication by 1/5. Okay, so let's see what we get with that. The 5 and the 1/5 cancel, and it looks like we have a y remaining on the left side, and 18 times 1/5 is 18 times 0.2 on my calculator, and that's going to give me 3.6. Let's do a quick let's do a written check here. Is 5 times 3.6, is that equal to 18? Let's go to my calculator and see. Yes, it is. 18 is equal to 18, so it checks out. So the answer is 3.6 here. And that's a good place to stop right there.